Hello everybody out there. We're on to question number 25. We finally made it. We're at the very end of the 2002 8th grade level Gauss math contest put out by the CEMC at the University of Waterloo. I do encourage you to try this contest. Click the link in the description. Try some of their other contests. If you found this one easy, move on to a Pascal paper. If you found it a little challenging, you need to brush up on your math, try one of the grade 7 Gausses. There's no shame, you're doing them privately. I'm not going to tell anyone. So, with that said, let's get to question 25 and finish this contest off. Okay? So, Emily has created a jumping game using a straight row of floor tiles that she has numbered 1, 2, 3, 4, all the way up to some number. Okay. Right? It is a finite number. Well, we don't know that. The dots make me think that maybe it goes on to infinity. Okay. Starting on tile number 2, she jumps along the row, landing on every second tile. So she goes 2, 4, then 6, 8, 10, and so on. Okay. And stops on the second last tile of the row. Okay. I'm guessing that we might have to figure out the number of tiles in the row, and if I jump down to the end, the number of tiles in the row could be. Okay. So second last tile in the row. So she goes 2, 4, 6, 8, and then eventually she hits the second last tile. So the first thing that tells me is that the second last tile in the row has got to be even. And that means that the last tile, the last numbered tile, has to be odd, and that immediately rules out B. So already now we have one of the answers eliminated. We have a 1 out of 4 guess if it came down to it. Let's see if we can improve that, or maybe even find the answer. Alright, so starting from this tile, this second last tile, she turns and jumps back towards the start, this time landing on every third tile. So if she bounce and bounce and bounce and bounce and bounce, and maybe A is the right answer, and she hit 38. Then she would go from 38 every third tile, so 38 down minus 3 to tile number 35, and then to 32, and then to 29, and so on. So after jumping on every third tile, she stops on tile number 1. Okay. So I'm sensing that we can create an equation there. Finally, okay, so she keeps doing some stuff. Finally, she turns again. So on tile 1, she turns again and jumps along the row, landing on every fifth tile. So from 1, then she'd go to 6, then to 11, then to 16. All right. Every fifth tile, this time she again stops on that second last tile. So if A is the answer, she'd stop on 38. The number of tiles in the row could be. Okay. So, we've got our work cut out for us, but we want the number of tiles in the row. Let's start out by giving that a name. And I'm feeling, because they're all integer numbers, let's call it N. So the number of tiles. So if we can figure out what N is, we're set. Okay? And very important, they said that N could be. I'm guessing based on this description, there's a couple values of N. I'm thinking modular arithmetic, so maybe every 80th value, or maybe 39 is the answer, but then maybe 39 plus 80 is a possible answer, and 39 plus 80 plus 80 is a possible answer, that sort of thing. So it looks like there could be lots of answers, but only one of these numbers here is one of the possible answers. Okay. So we want a plausible value for N that happens to coincide with one of these values. All right. So let's draw a little bit of a picture as to what's going on. Now we use that last tile a lot, that second last tile. And I think if I draw squares, it's going to clutter everything up. So 2, 3, 4, 5, 6, yada, yada, yada. And then she N minus 2, or N minus 1, and then N. Okay. So, on our first hop, there. Finally, she lands here. So as I said, n has got to be odd. B can't be the answer. Alright. Now from this n minus 1, she then turns around, and we'll add in a few more here. So now she turns around from here and hops on, every third one. So she'll go to 4, and then she'll go all the way down to 1. So, let's say this is her first hop, second hop, then she takes k hops to do this. I don't know what k is, but she takes k hops to do this. Actually, let's call it b hops. B hops. And we'll say this is 1, 2, 3, a hops. Okay. So now n minus 1 is 2a. But n minus 1 minus 3 times the b hops is equal to 1. So I can rearrange that and say n minus 2 is equal to 3b. So n minus 2 has to be a multiple of 3. So n minus 1 has to be even, n minus 2 has to be a multiple of 3. Okay. And then maybe n minus 3 will have to be a multiple of 5, and that'll definitely narrow some things down. Alright. So the last thing she does is she's on 1, and then she goes every 5th number. And then she lands on n minus 1 again. So the 5th one before n minus 1 will be n minus 6. And we'll use orange. So she starts at 1. Every 5th one is 6. One, 2, 3, 4, 5. Yeah, okay. And we'll say that that is c many hops. So 1, 2, that'll be c minus first hop. So starting from 1 and adding c hops of length 5, we get to n minus 1 again. So if we rearrange, we get 5c is n minus 2. So n minus 1 has to be even, and n minus 2 has to be a multiple of 3 and a multiple of 5. So in summary, n minus 1 is even, n minus 2 is a multiple of 3 and a multiple of 5. So n minus 2 is a multiple of 15. Okay, so we were given some possibilities. A, B, C, D, E. I think this one was 53. 39 and then 40. I think one of these was 47, but I'm guessing at this point. 47, 49. So these are our candidates for n. We need n minus 1 to be even, and we need n minus 2 to be a multiple of 15. So n minus 1 here, 38. 39, so that one's out. 46, 48, and 52. 51, 45, 47, 38, and finally 37. So, that one's out. And not a multiple of 15, not a multiple of 15, not a multiple of 15, not a multiple of 15. So we worked it all out. It was really, the challenge here was not drawing the conclusions from this point. The challenge here was setting up these pictures and translating them into an equation. That was the hard part, and maybe I didn't go over that well enough. But I tried to include sort of my language here, that even number of, A as our number of hops, B is our number of hops, C is our number of hops, and work those into equations. Now I don't know what C, B, and A are, and there's actually no way to work out what C, B, and A are, because there's bound to be another number that does this. Let's see here. 17 would also do this. So 17, 47, 77, it goes up by 30s. These all work. So there's no actual way for me to have worked out what A, B, and C are, because they change depending on what our answer is. But they don't change the fact that n minus 1 has to be even, n minus 2 has to be a multiple of 3 and 5, which we can summarize as a multiple of 15. So 17 plus 30, let's say D. So those ones all work, and in particular, C is our answer. Okay. And that wraps up question number 25, and that's the last one in part C. So you can compare your answers to mine. I might have gotten one wrong. I might have gotten a couple wrong. If you got a different answer than mine, leave a comment in the description. And of course, if you have any questions as to what the actual right answers are, the CEMC website, which you can get to by clicking the link in the description, it has the solutions to the past contests. They don't walk you through it in quite the detail I do, but they do have, they made the contest, so they definitely know whether or not C is the right answer here. So I've done all my math work, and my work points to C. And so hopefully you got C as well. But either way, that wraps up the 2002 Grade 8 Gauss. I'm going to go do the 2002 Pascal. So if you want to, you can download that and join me for that one. Or you can try another Grade 8 Gauss. I'll be moving on to the 2003. So you can click the link in the description, get a head start on that one if you want to. But that's it for me, so long for now, and thank you guys for watching as always.